All right, let's see, make sure the audio is working. Test, test, yes. Almost made the same mistake as last time. If you're interested in that festive lights thing, you can get it at Festivitas. I don't know how to say that. Festivitas.app. I'll paste that in chat. All right. Let's go ahead and get started. I actually want to tackle a quick script to prepare a day. I'm not quite sure how I want to do it, but if we look at what we need a folder in two places and then some stuff to put in package.swift. The folder stuff is the easy stuff to do. So I'm going to create a just file, and a just file is like a make file, but without all makes baggage. So you give it a task like maybe test, and then you give it the command you want to run. So this could be Swift test day 3 or something. And so then I can run just test, and it runs that command. And there's dependencies and arguments and stuff like that you can do. Let's see, what is the command to run tests when you have a package of multiple? If I run a Swift test, does it just run everything? Yeah, I think I need the filter. Okay, while that's running, let's open up the just file, because this is just an example. I want to, let's see, prepare. And I want prepare to take an argument. And I'm just going to pop open the just file syntax so we can see what's There's lots of examples here. Yeah, so this one depends on the build command. So that's how you do those. Examples, directory. Invoking multiple recipes. Sure, okay. Arguments. Oh, it just takes before. Okay. So we're going to echo preparing day, and then we'll put the $day in like that, or do we do it like this? I forget. Make this a little bigger. Yeah, let's just try it with these two. Oops, wrong one. All right, so if I run just prepare, it will say that we need an argument. So I'm going to say 4, and it says preparing day 4. And I think that generally I like to do this type of stuff in Ruby. And you can do it just inline here with, if we put in a a shebang. Yeah, so we can do user bin env Ruby like this. And then I can let's change that to a puts and make sure that it still works. Inconsistent leading white space. I think that was my fault. Okay, yeah, so this substitution still works. So now I want to have the folder is going to be day with the number, but I want it prefixed with, let's see, Ruby format number 2 digits. Format. Yep. All right, so we're going to do format and then %02d and then day. Let's put the puts the folder. Okay, looking good there. So now we can do, I'm starting to think that maybe this would have been easier with bash, but that's fine. So I can do make dir -p sources / folder, and then tests, and the tests here are also the same. So sources folder and tests folder. Then we're going to we're just going to touch sources folder main.swift. I guess since we're in here in Ruby, we could just do file utils .make dir p sources / folder. This is probably a little bit nicer. And we'll do tests as well. And then we can say file.write sources folder main.swift. Let's do file.open in writing mode. We'll do import AOC shared. Let's do a multi-line string. I'm writing bash, which includes Ruby, which includes Swift, which is pretty funny. All right, what else do we need? Probably the parsing library and maybe foundation. I don't know. We'll just do that. That's fine. And then we'll do the end of the string. All right, let's run this. I think this needs to go here. And then I think that these need to be outdented. I'm not quite sure how just file is going to handle that. Looks like not well. Maybe I'm forgetting. Ruby multi-line string. Oh, it's 2. That's why. There we go. All right, so let's look at sources, day 4. We'll take a look at what was created. And this tests. Yeah, perfect. Spelled foundation wrong. So I think that's close enough. Our package.swift is going to be trickier because I need to insert the executable, but this is actually quite easy to do once I have that. So maybe I'll just start from there and maybe tomorrow I'll improve it. Because now I can just copy this. This is in Swift though, which is kind of nice because then I think maybe I could just say we could have a func called executable for day, and that returns a package product, I think. Product. Let's do let name is day. Name, target's name. String has no member format. I think it's with format like that. What am I missing here? String format. Is this in Foundation then? No, this is standard. Init with format. Yeah. Let's do this in Xcode, just so I can avoid futzing with it. Oh, duh. Okay. And then executable target name. Okay, so now we have executable for each one. I think what we can do here one, 2, 3, 4. I kind of want to do this. Let products and then here I can say there's a library product. There's a day product plus all the library products. Okay, so that gets me those. Then I need the same thing for targets. Let day targets equals days.map target. Int gives me a target. Actually, 2 targets. So this is going to be compact map. No, flat map. So we just get one big array. And then this one will grab these and do the same thing. Func day name for day int string gives me this. Let name equals day name day. Then we're going to do kind of the same thing here. We're going to return the array, executable target, day name. I think they're all going to end up having the same dependencies, I think, just to make this easier. Oops, let's change this one to do that. Name. I'm not sure how I want to do that differently, but this is fine for now. This becomes name tests, dependencies, name, and name. String to a target dependency. What was it before? It was a string, but I don't think you can use static string there, so this ends up becoming dot target item name, dot target name. You can do that in one line. I keep doing command or colon W to write just from habit. I suppose that means that Xcode is becoming ever so slightly closer to Vim, that and my muscle memory gets confused. Okay, so if I have these helpers and I have all the products and targets, then I can delete all of this, and this becomes day targets. Except without the array. And so now when I add a new dependency, I guess just all of them are going to get it, which I suppose is fine. Okay, so now I just need to append onto this array, which I could do pretty easily. Let's move that up here to the very top. I could just look for this and append a new value to it using string replacement. Okay, let's see. That didn't work. What happened? AOC helper referenced in AOC helper cannot be found. Valid targets are day one test. Oh, I have an extra thing there. Okay. And my target. Oh, I deleted my, that one. So this one needs to also add the AOC helper one. AOC helper does not need Swift parsing. Product parsing. Package Swift parsing. Yes, that's what I meant. Let me take a look at the diff here, because this one has, yeah, those dependencies just need to be named like that. Hey Samuel, good to see you. I'm just organizing this package.swift so that I can just append days more easily. And now we have a day 4 folder. Sweet. Okay. We'll do struct day 4. Static func part 1. String. AOC helper, not shared. Let's fix that. Okay. Did I add? I didn't commit yesterday, so let's add sources day 2 and reset. Add sources day 2. Git commit finish day 2. Sources day 3 and test day 3. And day 3. Prep for day 4. Organize setup. Okay. Now we can go to Advent of Code. Let's open up day 4. Looks like the chief's not here. Next, one of the historians pulls out a device and pushes the only button on it. After a brief flash, you recognize the interior of the Ceres monitoring station. Throwback to 2019. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with her word search puzzle. She only has to find one word, Xmas. This word allows words to be... Word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. You need to find all instances of Xmas. Irrelevant characters have been written with this. Okay. In this word search, Xmas occurs a total of 18 times. Here, the same word search again, where the letter's not involved, and Xmas have been replaced with a dot. Take a look at the elf's word search. How many does it appear? Okay. Forgot you can find functions and stuff in there. Yeah, I don't often do that because I feel like I already ran into a case of like, what if I want different dependencies? And so now I may have overgeneralized, but it's fine. All right, so let's go into our test. Did I not create a test? Oh, I didn't. Let's do. We're going to do the same kind of idea here. Tests. This is going to be day. No, folder. Test folder. Then also folder tests.swift. This will import testing, and it will do @testable import and folder. Yeah, I think that's fine. Good enough. And that's going to fail if I run it again. So I'm just going to create a new empty file. Day 4 tests. Import testing. Day 4. Test sample, or we'll just sample. Let input is equal to this. Okay, and then if I run day 4 part 1, then we expect 18. Go to it, this takes input. It could throw, but I don't think we're going to. I'm not going to include parsing here because we don't need it. Okay. So as with a lot of these things, we may need a grid so that we can check words. It's not going to change, so it can be a struct grid. And then we could do grid of t, because we don't care what it is. We just want to be able to say that there are, we'll just call this data. And then rows is going to be data.count. Var calls is going to be that, and we need to guard that rows is greater than 0, else return 0. Okay. We need to grab an item. Let's do the index one, the subscript. So we can grab an item at row and column, but I want to do X and Y instead. Okay. And then we're also going to need a way to do points. But for now, let's just initialize the grid. So we'll say parse grid, func parse grid, input string gives us a grid. Let lines equals input dot lines, and this is something that I like from Rust, is that there's already a lines thing. I'm gonna put that in our AOC helper. String plus lines. That will give us an array of substrings. Yeah. Okay. Yeah, var lines. And then this is going to be a grid of strings. For each string, we're going to map that to the characters in the string. Is that what I want to do? I forget how to do that. Is it? I forget if it's a UTF-8 view. That gives us If I do for char in input, I get a character. Right? That gives me a character. So what is this doing to give me that? Now let's do input.lines.map line in. So I've got a line which is a string. If I do Unicode scalars dot map string.init, what does that give me? That's an array of strings. Okay. Let data is this, and let's init with data. Return grid with that data. Okay, let's make our grid custom string convertible. Description, and we'll just do this. Data.map row, row.map. This needs to be an extension so that we can do extension of grid T, where T is custom string convertible. So that this description moves into there, and I don't need to do string describing and all that jazz because we already know it's a string. We already know that we can get the description from this. And then joined, separator, nothing. Okay. Cannot find type T in scope. Declaration is only valid at file scope. That's going to be day4.grid. Return. We're going to print grid. And that needs to be static. Okay. Let's build day 4. Samuel, do you know how we can get let's do file.open. Sorry, one sec. Nope. Folder / input.txt. Goodness, I forget. I'm like losing all my Ruby. File.write foo bar should write bar in the foo file. Yeah, rm foo. Because we don't actually need anything in there. Okay, yeah, Samuel, question for you. Do you know, given that I have a day 4 target here, or scheme up here, how do I configure this to, so when I hit Command U to run, it runs the associated tests? In the package.swift, they are linked like this, where the test target depends on this, but there's no other reference to the tests. I don't know if you know how to do that. Because I'm having to go over here, then run the test. It switches me to the main scheme to run the tests. All right, so at this point, we're just trying to see if we can parse the grid. Looks like we're Find parse in the grid. Okay. So now we need to find, or we need to essentially walk every element and count how many times. So I think I would walk for an X, and then as soon as I find an X, check every direction. To see if it's the next letter expected. And once I find an M, I will check its neighbors except for the one I came from. So let's try that. So I like the idea that this grid is a type that we could use outside of here. So I'm gonna delete this, but I do need to put, like, the searching logic is gonna go into day 4. Let's move this up here. I may just put this in the share and the helper file later. Is that an option if you edit the day 4 scheme? I looked at that yesterday. So here's the scheme. It says test, but when I go over to test, it says that there's a test plan that's auto created and there's no test targets. And if I go to that, it says no tests here. I mean, okay, let's, I suppose that's what I want to do. So now if I hit Command U, nothing happened. Let's build it again. I never use test plans, so maybe that's part of the confusion here. Yeah, I can't do Command U, even though it says test here. This still says no test targets. Weird. Yeah, I don't know. Okay, let's do an extension on grid. This one will be private to this file, and we're going to func. Let's see. I want to be able to say search neighbors for a string, or in this case, a character. We could probably switch that to character, but that's fine. Well, let's just do search neighbors for a string. And that needs to come from one of the cells. So we're going to say from, and it'll be a point. So let's make a struct for point, which has an X and a Y. And let's make it easy to create these with no labels. Then here we'll make a func is inside point bool, and we can guard that the point.x is greater than or equal to 0 and point.y is less than or equal to the calls.count, and then we just need less than, and we'll do the same thing for the y, and that is rows.count. We can just return that expression. Calls, oh, yeah. Okay, so now we have a way to know if we're inside. Point also needs to be equatable. Okay. So now search neighbors from point for a given string. I wonder if I need to say I haven't messed with it to know exactly, but it seems like the solution is there somewhere. Yeah. That's kind of the hard part, is sometimes I will spend a lot of time futzing with the tools instead of doing the problem. What I'm actually thinking about for this search, say I started with X in this position, and then I want to search for the M in the next position, or sorry, in any position. It finds it here. So then M needs to search for A in the same place. So I think that this needs to be a direction instead of a point. And so this will be a relative point. Okay, and that can return bool. Okay, so if I say search for, and I'm going to do an extension on point, static var up, and hopefully Copilot will do the rest for me. Yep. Nice. Okay. Oh, and then I need diagonal. Let's just say upright. Up left, down right, and down left. Okay. Okay, so my current point I'm thinking. So basically I'm going to be searching for mass the first time, because I will be looping through until I find an X. As soon as I find an X, I'm going to have a starting point. Oh, I definitely need a from point and then the direction. So I have a starting point and a direction that I'm going to be searching for. So I need to move in that direction, which means I need the ability to add 2 points. Static func plus and subtract maybe. Oh, this is dangerous. I actually don't need to subtract, so that's fine. Never trust Copilot. All right, so let's say I'm going in the direction. So let next is going to be from plus direction. And then I'm going to let the character to search for. I think I want this to be an array. No, these are all characters. So I think what I want to do here is change this to character. The thing that I'm not quite sure about is where we're extracting the data here. Unicode scalar view. What's the easiest way to turn a string into an array of characters? Array string. Wow. I would not have guessed that. Okay. So, array of line. And now this should give me a grid of character. Okay. So now this is going to be an array of characters as well. So let target is characters dot pop. Drop first. No. I want to pop. I don't think there is a remove for. Yeah, that's what I want. Okay. Guard characters dot is empty, not else return false. Okay, so we get the target, and then we need to look at self for next.x and y is the target. If this is the target, then we're going to search for characters. This needs to be an in-out character so that we can... No, we'll just make a copy. So we make a copy, we remove first. If this equals target, then we will recurse. Let's just change that to a guard. Else return false. And now, if the characters is empty, we're done. We can return true. Let's see, we need an extension of grid where T is character. Oh, come on. Constrained to non-protocol, non-class type character. No, where T equals character. That's what we want. I was going to say, how did that not work? Okay, make sure that the target that we're looking for is there. If there's no more characters to search for, then we're done. Otherwise, we're going to search for from next, which is the one we're on right now, in that duration for characters. Okay, so now I can walk the loop. It would be kind of nice if grid had an iterator of points. I may just be like sugarcoating here, but it would be nice. Data is... All right, I'm not going to do it because I don't know what part 2 has in store. All right, so we've got our grid. I will say for row in grid.rows, or call in grid.calls. If, all right, so let's make a point out of that. Call row. We'll get the character at that grid. And if the character is an X, then we're going to say grid.search neighbors. And we're going to have to do this for each one. Let chars to search is M. Oh, I can do the array trick. Array MAS. Okay. From the point we're at in the direction, so we need to have let all yeah, in all directions. Let's do var count is 0. If grid.search neighbors, this needs to be we could do count plus equals all dot filter from point to the dir for the chars to search. Okay, and then I just want to count those. There's probably some optimization here that I could be avoiding because I don't want to walk backwards over letters I've already seen, but since I'm always starting from an X and this letter is not in the word again, that's, I think, maybe what part 2 is going to have, is some kind of thing that'll mess me up, but this should be simple enough for now, and then we'll return count. All right, let's switch over to the tests. Switch and run tests. Okay, index out of range. Did I not check is inside before doing that? I thought I did. Y is -1, so it's trying to get that next.x and next.y. Yeah, we need to check to see guard is inside next, else return false. Okay, again, we got it. This time it was in the search. Is inside, greater than or equal to 0 and less than columns. Oh, this. All right, that'll do it. I don't remember if that was my mistake or Copilot's, but it's my mistake for not catching it. Okay, so we got our first example. Let's grab our huge grid. I'm gonna delete the print here. And then go to our input. Paste it in. And let's grab this stuff from here. Day 4, part 1. All right, let's see. What was our... $30 and $140. And our columns is $140. And our rows is $141. How did that get out of range? X and Y Y is 140, and we have 141 rows. And then we have X is 30. Oh, they're not all the same length? Let's see, P data.map $0.count. So each row is 140 columns. Oh, the last one is 0. Okay, we need to trim empty rows because I have a new line at the very end of the file. Where do I have that? Parse grid. Filter. Not as empty. I think instead of that, I could just do input dot trimming characters in white spaces and new lines. Okay. All right, continue to part 2. The elf looks quizzically at you. Did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find your... It isn't actually an Xmas puzzle, it's an X-miss puzzle in which you're supposed to find 2 MAS in the shape of an X. Oh. One way to achieve that is like this. Irrelevant characters have again been placed with a dot. Okay. I think we can pretty much use what we've written so far. In this one, it occurs 9 times. So let's copy that. Let's go back to our tests. This is going to be func sample part 2. Let input equals this. All right. I think that actually, no, it's like this. Okay. Output part 2 input and expect the output 9. So I think in this case now we're going to be searching for an A, and from there we're going to check to see if there's MAS in the diagonals. All right, let's copy part 1, part 2. Here, if the character is A, then the character is to search here. It's almost like I want to reflect over it and then search for MAS. But it could also be backwards, right? Sam, yeah. Well, no, that would work, I think. I think what I could do is take the direction I want to search for. Like, say I want to search for this one, and I'm going to reflect over this point to get this one, and then search in this direction for MAS. I think I have everything in place to do that. So if it's A, we're going to be searching here. The places we want to search for are going to be only the diagonals. That worked out that I wrote it like this. The thing is the point I'm on is not where I want to search. I want to now search opposite this one. So I want to reflect dir over current point. So if I do this, that's not dir, but that's going to be let start equals point plus that one. And then we can search from that starting point for those Is that all it takes? It would help if I add the test attribute here. Expectation output was 0. Okay, let's jump into it. Okay. Let's go until we get an A. Okay, so our point, I should have done a string convertible on this one. So we're at 2, 1. Our grid looks like description. So we're at row 1, column 2. So we're here. Can you see that over my face? Probably not. I'll move myself over here. So now our direction that we're going to be filtering over, let's go to that one. Our direction is going to be to the right and up, and we're not going to find an M. So let's skip again to up and to the left. We are going to find an M. So we're going to search neighbors for chars to search, MAS. So let's step into that. Oops, I stepped over. There's one more we can check, which is y2x, or sorry, y1x minus 1. This one. So we'll step into characters is not empty. Is inside next. We're looking for the target. The target character is M. It should be an M. What are we? Target is M, and the next point is X2, Y1. Why am I there? We started from X3, Y0. 1, 2, 3. No, we didn't. From. How did we get there? This is wrong. Our starting point is 2, 1. So here's our starting point. Our direction is to the left and down. So the reflected point would be to the right and up. Oh, that is correct. Yeah, and the value and the letter is S. So it just needs to keep going because yeah, I need to go. It needs to be searching for this one in order to start here. Kind of weird, but I guess we could. We could simplify that a little bit by checking for an S before starting, but that's kind of the point of the search neighbors. I mean, it does it inside of it. Okay, so now we're at x minus 1, y1, so we're here. That's the direction, so it's going to start over there and not find it. So let's skip over that. And we missed our window. I need to step away for just a minute. I'll be back in probably 2 or 3 minutes. All right. Where was I? Point is 2, 1. Let's print the grid. So row 1, column 2, we're here. So we're going to start in the upright position. And this one should find it, right? No, this one will not find it. So we need to go to the up left position. So this one should have found 2 of them, but didn't. Okay, so this is the up left position. The starting point becomes 3, 2, which is here. That should be an M. So that's going to be grid at 3, 2. No, that's not right. Do I have those backwards? No. Wait a second. My point is 2, 1. We need to add the opposite of dir x and dir y. Yeah. So the opposite of -1 is 1, so we get 3. 0, 1, 2, 3. So it would be here. And then the opposite of -1 is 1, and we'd add 2. Sorry, that's in, yeah, 0, 1, 2. Okay, so that is correct. I think my... Let's see. We did grid at point.x and point.y. This should be an A. Okay. And if I do x minus 1, point y minus 1, so that is to the upper left of it, we get an M. Okay, so that's correct. So why did that? Point.x is 2. Oh, I'm looking at start. Point.x is 2. And we're subtracting 1. What am I missing here? Simple math. Before I go too much farther, I want to make my debugging life a little easier. I don't even need the labels here. Well, labels are fine. So if I do grid at the start point, start.x, start.y, I get S, which is not what I expected, because we're going to start from S and go in the direction of top left. So it's going this way. Oh, that is correct. Okay. So it won't find it there. Oh, and our debugging is wrong, so let's start over. All right. If I start in the in here, the start point is x1, y2. So this one should find it. Our direction is to the right and upright. So it should find it here. So we go in. Our next character is going to be from our starting point in the direction. So the next one should be an A. Oh, that's why. We're not looking for MAS. We're looking for... Yeah, that's my problem. In the previous example, we found the X and then searched for the remainder of the letters. In this one, we can't even start searching unless we have the correct letter. So here we're saying if the char is A, that's where we're starting, but the starting letter has to be M. So if we do current is point plus dir, and we need to guard that the yeah, we need to make sure that the point yeah, we need to do grid.isInside current. Wait, no, we already have start. That's what I need. I need to guard that the grid.isInside the starting point. Else return false. And then we also need to guard that this is our first letter. That grid to search, oh sorry, grid dot at this point. I also want to make a subscript while I'm at it. To do, where is it? Here. Okay. I think I just need to make sure that this is an M. And this becomes an AS. Okay, test failed here. We got 18, but we should have gotten 9. Okay. MAS, so that should have gotten me 2. Let's do a smaller test. I don't remember how to do that. I'm not going to bother with it at the moment. I'll just comment it out. We're going to do just a smaller grid of just this. Well, yeah, this should just be 2. Okay, so that worked. So this one's fine. When we get to this one, this should also be 2. When we get to this one, that one should also be 2. This one would work. How did I get 18 out of that? I go until I find an A, and then I check the 4 corners. Then I go until I find an A, and I check the 4 corners. A, check the 4 corners. There's no chance that that counts the A twice. Hey, class. Thanks for joining. And it was freezing cold yesterday, and now it's 60 degrees outside. $60 in freedom units. One thing about me streaming early is it's mostly people from Europe on my stream. I don't quite see how I could get 18 here. But let's print out some diagnostics. So let found equals this. If I found it, we're going to if we found it, we're going to print found, and then I want to print the start position. And then start plus dir and start plus dir maybe. And then that should equal I don't know what I want to say here other than I suppose getting the letters would be helpful here. So that's going to be grid start. Grid start plus dir. Plus dir. Okay. So if I run the test again, we'll see that one. Let's run the original test. That should be 9. Okay, so do I have any duplicates here? So in the X's, I've got 1, 2 here and 1, 2 here, but the Y and the next one is different. All right, let's trace these out. So X1, Y2, so I'm here. Then X2, Y1, so that's this one, MAS. Then X1, Y0, X2, Y1, X3, Y2, so that's this one. Those first two are correct. The third one, X5, Y1, 1, 2, 3, 4, 5. And then 6 and Y2, which is here, and 7 Y3. So that one's correct. I feel like these are all fine. Let's grab this one. X8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3 is this one. Then 7 and Y is 2 is this one. Nope, that one. MAS, that one's correct. X0 on the 8th row. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's this one. Then 1 on the 7th row and 2 on the 6th row. Am I correct? Like, this seems fine. In this example, flip the word search to find the... Isn't actually Xmas puzzle, it's an X-Mas puzzle in which you're supposed to find 2 MAS in the shape of an... Oh, 2 of them. Oh, I was just finding the individual ones. Okay. That makes... that does make more sense. Okay. So... I need this to only increment the count. We're going to do this. Has X equals the filter. And then that's an X if that equals 2. If has X... count plus equals 1. And test succeeded. Okay, let's run part 2. Day for part 2. $2046. That's the right answer. 1 gold star, closer to finding the chief historian. You've completed day 4. You can share this victory on Mastodon. Let's do it. Sweet. All right. Thank you for joining on day 4. I will be back tomorrow for day 5. at some point, I'm going to have to find a way to do these a little faster. Just because I run out of time every day, and then it puts the rest of my day in a bind. Anyway, thanks for joining. We'll see you tomorrow.